Okay, welcome back to our discussion more on the graphs. So, as we know there are varieties of functions we come across in mathematics, and also these functions are useful in physics. So, we will discuss some of those graphs of some typical functions. In the last class, I discussed about an absolute value function, odd functions, even functions, and we have found that odd functions are symmetrical about the opposite quadrants, while even functions are symmetrical about the y axis. Okay. And you can suppose when you define y is equal to x square, means your function of x is equal to x square. What is the domain of x? The domain of x is all the real numbers, but what is the range? Sorry, domain of x, the domain of the function. Domain of the function means the set of all values of x, and here x can assume any values of real number. Okay. So, the domain is real number. While what is the range of this function? The range is only positive values, positive real numbers, because x square is always positive. So, you can see how the domains and range are different here. Okay. When you say y is equal to x, this function, here x belongs to the real number, any value of real number it can assume. So, the domain is real number, while range is also the entire real number, because y can take all the positive, negative fractions, all values of values, I mean all values of the real numbers. So, the domain is real number, range is also real number. When we consider y is equal to absolute value of x, then here again x is the real number, I mean the domain is the real number, while mod of x is always positive. So, range is only positive real numbers. Okay. So, this is how we define the domain and range. Let us now discuss a typical function, greatest integer function. Greatest integer function. It is written as the symbol f of x is equal to greatest integer function. That means your f of x value is the greatest integer less than or equals to s. The value of x is the I mean the value of y, here y is equal to f of x, y is greater than, is the greatest integer, is the greatest integer less than x. Okay. Suppose that means y is equal to, you can see when x lies between 0 and 1, when x lies between 0 and 1, your y value will be the greatest integer less than x, okay, less than, here less than 1, 0 less than x less than 1. So, x goes from 0 to say 0.999 and so on. So, between that the greatest integer which is less than x is 0, okay, because 1 will be more than x. So, the value is 0, and when x lies between 1 and 2, then the greatest integer which is less than x is always here 1. Okay. So, for x is equal to 1.4, the integer less than x is 1. For x is equal to 1.5, the integer less than x is 1. For value of x 1.7, the integer less than x is again 1. So, it is 1, so on. So, when x lies between 2 and 3, the function value is 2, so on. So, the graph will be like this. How? This is x, this is y. So, when x from goes from 0 to 1. The greatest integer value is less than 1 is 0. So, the y points are all these. So, this is the graph. When x changes from 1 to 2, the y value is 1. Okay. When, so this is our greatest integer function. When x lies between 0 to 1, the value of x, which is the greatest integer, less than x means it is 0, because for 0.1, 0.2, 0.3, 0.4, the integer less than x is 0. Okay. Similarly, when x value goes from 1 to 2, the greatest integer less than x is 1, so on. Okay. And you see these circles I put at the end, those are the values not, I mean, then this value is not attaining 2, it is less than 2. Here it is less than 1, here it is less than 3. Okay. And in the negative axis, similarly, we will have the greatest integer less than x will be like this, exactly similar. Okay. So, this is called our greatest integer, the graph of greatest integer function. You can see here, when we plot the function, you just visualize it. Here this function loses a continuity. Okay. There are breaks in the graph. Okay. That lose continuity, which we will discuss later as the continuity of a function, which is again very important. Okay. And if we find out the domain, here domain is the entire real number. Okay. For the greatest integer function, the domain is entire real number. X can have value all the fractions, integers, everything. But what about the range of the function? What are the values of y? Y is 0 or 1 or 2 or -1 or -2 or -3, so on. So, these are integers only. So, you see the greatest integer for this greatest integer function, the domain is all the real numbers, while the range is the integers only. Okay. Suppose I define a function like this, f of x is equal to half when 0 less than or equals to x less than half, and is equal to 1 minus x when half less than x less than or equals to 1. Okay. And it is equal to 1, when x is equal to half. Let us plot the graph. Obviously, this is x, this is y. From 0 to half, suppose this is 0, this is 1, this is half. From 0 to half, y value or function value is x. That means y is equal to x, the graph is straight line. At half, as long as it is less than half, it is like this, but at half, say this is half y value and this is y value 1. At half, the y value is 1. So, this is the point half and 1. Beyond half, it is 1 minus x, again a straight line with a negative slope. Okay. So, it is like this, this is 1. So, you see this graph is again, we plot this graph, there is a break at half, in the graph there is a break at the half. So, it loses continuity over here. Okay. So, we have discussed different types of graphs. When we plot y is equal to x, when we plot y is equal to x square, when we plot y is equal to x cube, the function is very continuous, there is no break in the graph. But when this type of functions, greatest integer function or this particular function, we find a break in the graph. Okay. So, when there is a break, the function is discontinuous at that point. When there is no break at a point, then that at that point the function is continuous. We will discuss again more about this continuity of the function. Let us discuss some more about different types. Let us discuss about trigonometric functions. You know trigonometric function y is equal to sin x, y is equal to sin x. X can have value, any value in the real numbers. And what is the value of y? The maximum value of sin x is plus 1, minimum value is minus 1, and at x 0 y is 0, and the graph is like this, and it is a periodic function. So on. This is plus 1, this is minus 1. The function is a periodic function. This kind of function is called periodic function. When y or f of x is equal to f of x plus k, means after a particular value of x the function repeats, then that kind of function is called periodic function. You can see here x is equal to 0, here it is pi by 2 if I take in radian, and then it is pi, okay, and it is of course 3 pi by 2, this is sorry this is 0 pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, and here it is 5 pi by 2, so on, okay, and it is 3 pi and it is 4 pi, so on. So, you can see the sine function repeats after 2 pi. So, the period is 2 pi, after 2 pi again the function repeats, okay. This is called a periodic function, and the graph is quite continuous, okay. There is no breaking in the graph, and the range is the entire real numbers, sorry domain is the entire real number, but what is the range? Range is between minus 1 and plus 1. So, range is the interval minus 1 plus 1, this is the range of sin theta, sin x. Similarly, if we plot y is equal to cos x, y is equal to cos x, then at x is equal to 0 cos x is plus 1. So, the graph is like this. Zero pi by 2 pi 3 pi by 2 2 pi, so on. So, from 0 to pi by 2 it is monotonically decreasing function, while in sin x from 0 to pi by 2 it is monotonically increasing function. Again it is a periodic function, you can see after 2 pi again the function repeats. So, the period of the function is 2 pi. So, this is cos x, y is equal to cos x. Let us plot y is equal to tan x. You know tan x, x is equal to 0, tan is 0, but when x is equal to pi by 2, tan pi by 2 is infinite. So, this graph, if you plot this graph tan x, x, y 0, pi by 2, here minus pi by 2. 3 pi by 2 minus 3 pi by 2. So, at 0 it is 0, but at pi by 2 it approaches infinite. That means the graph is like this. Again the graph will be like this. So, you can see the function is here, the graph is breaking at here at the point pi by 2. There is a loss of continuity over here for the tan x, and this is not the situation in case of sin x and cos x. Okay. So, this is our trigonometric function. Let us discuss about exponential function. Suppose we consider y is equal to a to the power x, then whether x is positive or negative, y is always positive. For example, if x is equal to 2, it is a square. For x is equal to minus 2, it is a to the power minus 2, which is again 1 by a square, which is always positive. So, the value of y is always positive for this kind of function when y is equal to a to the power x. Now, two possibilities are there. A may be greater than 1, a may be less than 1. Let us first see what happens when a is greater than 1. Okay. For a greater than 1, when x is equal to 0, y is equal to 1, this is the point. Okay. When x increases, y is equal to, suppose x is 2, y is equal to a square, x is equal to 3, y is equal to a cube, x is equal to 4, y is equal to f4, means the power is increasing, the value is increasing, the graph is increasing. Okay. When x is minus increasing, suppose x is minus 2, it is 1 by a square. When x is minus 3, it is 1 by a cube. When x is minus 4, it is 1 by a4. So, it is value decreasing. Okay. In the denominator it is increasing, so the ratio is decreasing. And when x tends to minus infinite, y tends to 0. So, the graph is like this. Graph is like this. It will tend to 0 when a is greater than 1. But what happens when a is less than 1? When a is less than 1. When a is less than 1, if the value of x goes on increasing, again when x is equal to 0, a is equal to, y is equal to 1, obviously the graph will intersect the y axis at 1 always, whatever the value of a may be. But suppose a is equal to say 1 by 2, okay. Then when it is its power is say 2, 1 by 2 power 2 is 1 by 4. When x is 3, it is 1 by 2 cube is 1 by 8. When x is 4, it is 1 by 2 to the power 4, 1 by 16. So, value is decreasing. So, here as x, the positive value of x is increasing, y to the power x is decreasing. But when x, the negative value of x is increasing, I mean when x is equal to say minus 2, when x is equal to minus 2, it is 1 by 2 to the power minus 2, means 2 to the power minus 1 to the power minus 2 is equal to 2 to the power plus 2. When it is minus 3, it is 1 by 2 to the power minus 3, means 2 to the power minus 1 to the power minus 3 is equal to 2 cube. So, it is 4, it is 8. So, it is monotonically increasing now in the negative x axis. Therefore, the graph is like this. And as x, the value x approaches towards the positive value, it is decreasing. Okay. So, this is when a is less than 1, that is the situation when a is greater than 1. These are called exponential functions, graphs of exponential function. Now, let us discuss about logarithmic functions, graphs of logarithmic functions. Logarithmic function means y is equal to log a to the power x, means x base a. Okay. We can write it as a to the power y is equal to x. If y is equal to log x base a, then our x will be equal to a to the power y. Okay. So, when a greater than 1, this is our x axis, this is our y axis. Okay. When y is equal to 0, x is 1. When y is 0, x is 1, means the graph will intersect here to the x axis. Just you invert the x and y axis in the previous case when we are discussing about exponential functions. As the positive value of x is increasing, let us discuss in this way. As the positive value of y is increasing, a is greater than 1, positive value of y is increasing, means y is suppose 2, 3, 4, then x is equal to a square, a q, a 4. So, the value of x also increases. So, the graph is like this. And what about the negative values of y? Suppose y is equal to minus 1, x is equal to 1 by a, y is equal to minus 2, x is equal to 1 by a square. So, the denominator is increasing, means ratio is decreasing. So, the graph, the value of x is decreasing as the negative value of y is increasing, and it is approaching to 0 at infinite. So, this is the situation when a is greater than 1. This is the plot of y is equal to log x base a. This is the logarithmic function. Logarithmic functions. Then what about the situation when a is less than 1? This is x axis, this is y axis. Okay. Now, again when y is equal to 0, x is equal to 1, obviously y is equal to 0, x is equal to 1. So, the graph will intersect at the x axis. But as the y value is increasing with positive values of y is increasing, means it is a square, a q, but a is less than 1. Suppose a is 1 by 2, then 1 by 2 square is 1 by 4, 1 by 2 q is 1 by 8, so on. So, the value of x will go on decreasing, means as y is increasing, x value is decreasing. The graph is like this, and when y tends to infinite, it extends to 0. What about negative values of y? For when y is equal to minus 2, it is 2 to the power minus 1 to the power minus 2 is 2 square, it is 4. When it is minus 3, it is 2 q, 8. So, it goes on increasing. The value of x is increasing. So, this is the situation for a less than 1. So, these are the plots of logarithmic functions. So, as I told, there are many types of functions, okay? And out of those functions, some important functions we have discussed regarding their graphs to visualize those functions, because graphs gives you the visualization of the function, so that you can easily perceive the concepts when you are explaining some physical theories, because we are reading here mathematical tools to understand the physics. Okay. And I have given you some hints about the continuity. Suppose this function, in the graph you do not see a break anywhere. So, this function is continuous. Okay. But while in the greatest integer function we show that there is some, there are breaks at the intervals, at certain intervals. So, these are discontinuous functions, and we shall discuss more about continuity of a function, limit, though you have been taught again at the 12th level, we will just again make a review of that. And so, in the next class we shall discuss about continuity, limit and differentiability, and till then thank you.